On July 16, 1945, mankind entered the atomic age. In a remote desert in New Mexico, the first atomic bomb was detonated. They called it Trinity Test. Crafted from a tennis ball-sized plutonium sphere, the Trinity bomb produced an explosion equivalent to 20,000 tons of TNT. It created an enormous mushroom cloud, 40,000 feet high. Nuclear power has been championed as a source of affordable energy, but this was undermined at the end of the 20th century by high-profile reactor accidents. More than 34 years ago, the largest nuclear accident at the Chernobyl nuclear power plant shocked the entire world and led to the horrific aftermath of a nuclear meltdown that rocked Ukraine in 1986. 25 years later, another nuclear catastrophe unfolds in Japan. After the magnitude 9.0 Tohoku earthquake and subsequent tsunami triggered a disastrous system failure at Fukushima Daiichi nuclear power plant. These are the only two nuclear accidents in the world that were classified by the highest, 7th level of hazard. They are essentially completely different, but is it possible to define which one of those was worse, and can they be compared at all? Located about 16 kilometers from the Belarus-Ukraine border and 130 kilometers north of Kiev, capital of Ukraine, Chernobyl nuclear power plant consisted of 4 nuclear reactors of the RBMK-1000 design, each producing 1000 megawatts of electric power. RBMK stands for High Power Channel Type Reactor. Units 1 and 2 were being constructed between 1970 and 1978, while Units 3 and 4 were completed in 1981 and 1983. Units 5 and 6 were under construction, which was suspended and eventually cancelled in April 1989. The core of the RBMK reactor has a form of a vertical cylinder. The reactor core is constructed from closely packed graphite blocks. They are stacked into columns with vertical cylindrical openings into which channels for fuel as well as channels for absorbing rods are inserted. The core is surrounded at top, bottom and lateral by graphite reflectors. Cooling of the RBMK reactor is assured with help of 2 parallel loops. The Fukushima Daiichi nuclear power plant is located about 260 kilometers from Tokyo on the northeast coast of Japan. It was one of the largest power plants in the world. In total, the station had 6 boiling water reactors, which together had a power generation capacity of 4.7 gigawatts. Fukushima Daiichi was the first nuclear plant to be constructed and operated entirely by Tokyo Electric Power Company TEPCO. Reactors 1, 2 and 3 came into commercial operation between 1971 and 1975. At the time of the Tohoku earthquake, reactors 4, 5 and 6 were shut down in preparation for refueling. The reactor is a steel vessel in a 2-layer pressurized shell. The inner layer is made of steel backed by reinforced outer concrete shell. The uranium oxide fuel is placed in the fuel rods within zirconium alloy cladding, preventing contact with water and fuel. Control rods are placed on the bottom, as at the top there is a separator together with a steam dryer. Water is used as a moderator and coolant. Water passes through the reactor core and turns into steam while removing heat. The Chernobyl accident occurred during an experiment to test a way of cooling the core of the reactor in an emergency situation. The reactor number 4 was to be shut down for routine maintenance on April 25, 1986. During this period, it was decided to determine if the slowing turbine could provide enough electrical power for coolant pumps until the diesel emergency power supply became operative. For this test, the reactor should have been stabilized at about 1000 megawatts, but due to operational error the power fell to about 30 megawatts. The operators then tried to raise the power to 700 to 1000 by switching off the automatic regulators and freeing all the control rods manually. At about 1 a.m. on 26th of April, the reactor was stabilized at about 200 megawatts. In order to maintain power, the operators had to withdraw nearly all the remaining control rods. The reactor became very unstable. Simultaneously, the pumps that were powered by the slowing turbine were providing less cooling water. The sudden increase in heat production ruptured part of the fuel, and small hot fuel particles reacting with water caused a steam explosion, which destroyed the reactor core. A second explosion added to the destruction 2 to 3 seconds later. The build-up pressure was so immense that it blew the 1,000-ton reactor lid, made of steel and concrete, through the roof of the building. Explosion caused the fire, which extinguished by 6 a.m. in the morning, except for a blaze in the reactor core. The fire inside the reactor number 4 continued to burn until 10th of May 1986. On March 11, 2011, a magnitude 9.0 earthquake struck in the Pacific Ocean off the northeast coast. As a result of this earthquake, the strongest in the country's history, tsunami hit many coastal areas of the country, sweeping away everything in its path: buildings, ships, cars, people. The damage from the disaster was devastating. The same day, tsunami wave more than 10 meters high hit the Fukushima Daiichi nuclear power plant, flooding the lower floors of the station. As a result, units number 1, 2 and 3 of the plant lost power supply and were automatically shut down. In the first minutes of the accident, the backup diesel generators located in the basement were flooded, which led to the automated disconnection of the 3 power units from the power supply. Emergency batteries lasted only for a few hours. Due to insufficient cooling, the coolant level began decreasing, and the vapor pressure in the upper parts of the reactor continued increasing. On March 12, the first power unit of the nuclear power plant exploded. The reactor vessel was not damaged, but the outer reinforced concrete shell of the building was destroyed. On March 14th, a hydrogen explosion occurred at the third power unit, and on the morning of March 15th, the pressure compensator of the second power unit exploded. A majority of the fuel in reactor 2 dropped to the bottom of the reactor pressure vessel. On the night of March 16th, a fire broke out in the spent fuel storage at the fourth power unit, which lasted around 2 hours and caused radioactive substances to enter the atmosphere. The first news of the Chernobyl accident appeared only 36 hours after the initial blast, when the USSR State Commission decided to evacuate the inhabitants of the neighboring town Pripyat, the closest city to Chernobyl, with a population of about 50,000 people. Around noon on April 27th, they announced a temporary evacuation of the city residents. To reduce the amount of luggage and prevent panic, people were told that they could return home in 3 days. The evacuation of people from the Fukushima Daiichi nuclear power plant area began on the evening of May 11th. As a result, a total of over 400,000 individuals were forced from their homes, 160,000 of them from the within 20 kilometers of Fukushima. The annual permissible dose of radiation that the population could receive in the event of refusal to evacuate exceeded 20 times. The initial radius of the Chernobyl zone was set at 30 kilometers. Large areas, about 150,000 square kilometers of Ukraine, Belarus and Russia were contaminated, and about 200,000 people were displaced. During the 30 years since the Chernobyl disaster, about 1,000 people illegally returned to their homes in a closed zone. Most of them are older people. Tokyo initially ordered a 20 kilometers radius exclusion zone around the plant, with the possibility of expanding by 10 kilometers. 5 years after the Fukushima accident, many of the evacuees still live in temporary homes. They have the right to visit their homes in a closed area for 5 hours in one visit. Immediately after the Chernobyl accident, 31 people died. Later, radiation killed several thousands of people. Disputes over the final number of accident victims continue to these days. Thousands of cases of thyroid cancer among children and adults exposed as a result of an accident have been recorded. In Japan, 15,000 people died in the most affected prefectures as a result of natural disaster. More than 2,000 remain missing. Deaths due to radiation leakage were not officially recorded. At Chernobyl, straight after the accident, a concrete sarcophagus was built over the destroyed reactor number 4 to avoid further leakage of radioactive dust into the atmosphere. The sarcophagus, or so-called shelter object number 1, was mounted from June to November 1986 in only 206 days. This goal could only be achieved at the cost of the health and lives of thousands of people. Soldiers were brought in to clear the roof of the reactor from the radioactive graphite and pieces of fuel assemblies. In July 2019, a monumental arch named as the new safety confinement was commissioned, which allowed to cut the emergency block together with the old shelter, which started cracking and leaking radiation. The new safety confinement was designed to last for 100 years. At Fukushima, nuclear fuel melted and accumulated at the bottom of the first, second and third reactors, causing a triple meltdown. At the first, third and fourth power units, explosions of the generated hydrogen damaged or completely destroyed the roofs. A domed roof will be installed above the destroyed buildings to safely discharge the equipment and the remaining spent nuclear fuel rods from the cooling pools. The most difficult task is to extract melted fuel or so-called corium, including reactor components, concrete, shell steel, sand, from the heart of the reactors of units number 1, 2 and 3. Nowadays, preparations are underway for the unloading from the first unit, starting with the collection of minimum laboratory samples for initial studies. Complete liquidation of the consequences of the accident will take 40 years. Numerous measures have been taken to avoid further pollution of water through underground rivers, groundwater and rainwater, which may harm the planet's ecosystem passing through the station. For example, around blocks number 1, 2, 3 and 4, a special ice wall was created to freeze the ground. In July 2019, the liquid radioactive waste processing plant started at the Chernobyl site. According to the procedure, the liquid waste passed through several stages and turned into the solid waste by cementing. Gradually, the plant should go to the processing of 42 barrels of 200 liters each per day. Also, electricity generation has begun again on the territory of the Chernobyl nuclear power plant. A solar power station with a capacity of 1 megawatt recently opened 100 meters away from the exploded reactor number 4. In the future, a successfully completed project is going to scale up to 100 megawatts. Soon, a similar solar station will be built in Chernobyl town. Ultimate plan for decontamination and decommissioning of the Fukushima Daiichi nuclear power plant is expected to take anywhere between 30 to 40 years. Colleagues from different countries help Japan to meet these deadlines. The United Kingdom is developing a unique system of a robotic manipulator with remote control to study the nature and location of melted nuclear fuel inside the reactors. France helps in scientific research related to laser cutting of the fuel corium. United States projects are related to the design of containers for the storage of highly radioactive fuel collected from the damaged reactors. Russia makes an approximate assessment of the characteristics of the fuel melts and the influence of external factors on its degradation. Chernobyl and Fukushima are 25 years and half a world apart. At first sight, the reasons which led to accidents at both plants are different. The explosion of the fourth Chernobyl power unit was a result of tests conducted by the station staff. The accident at Fukushima occurred as a result of natural disasters, an earthquake and a tsunami strike. However, errors in reactor structure and negligence were among the causes of the both events. Chernobyl and Fukushima are two horrific catastrophes but share one tragedy which cannot be forgotten.